Hello students, we are learning program in Bachelor of Science, subject Electronics. Course title is Electronic Circuits and PCB Designing, Semester 1. Module name is Soldering. Principles of solder connection, solder joints, solder alloys, soldering fluxes, soldering and desoldering tools and techniques. This is the outline. These are learning outcomes. So first we'll see introduction to soldering. Now solder is used to make electrical connections. So a soldering iron is used to heat the metal, which is called as base material of the solder part to be soldered. A solder is then melted onto the metal due to wetting and a capillary action to create an alloy of metal and solder at a connection surface. Now we'll see what are the components of solder. There are many kinds of solders. First is lead containing solder. It is commonly used. It is the most commonly used. Now, however, lead-free solder has become general due to environmental consciousness rising. The most well-used lead-free solder is SnAgCu type, composed of 96.5% tin, 3% silver and 0.5% copper. The melting point of lead containing solder is approximately 183 degrees. On the other hand, it is higher from 217 to 219 degrees in lead-free solder. Wire solder is popular for soldering. It has a structure whose outside is covered with solder alloy and flux in the center. Now, what is base material? Now, a base material is the metal that is soldered. Now, conditions of the surface of the base material. Now, the surface of the base material is covered with many obstacles to soldering. The metal surface that looks clean at first glance is actually covered with a lot of fine dust and as well as surprisingly large amount of fats and oils. In addition, if the base material is left exposed to air, it combines with oxygen to form oxide film. Now, shape of the base material. Since the shape of the base material greatly affects solderability and bonding reliability, the following conditions must be satisfied. So, the base material must be mechanically and securely fixed, otherwise it could move, resulting in cold solder joints. The base material must have appropriate clearance. The temperature of the entire joint area must rise the same amount at the same time. The structure of the base material must prevent the solder from flowing to unnecessary locations. The structure of the base material must prevent the flux from splattering to dangerous locations. Parts that are sensitive to heat must be protected. There must be no stress applied to the joint areas. What is flux? The flux used in wire solder is made by adding chemicals to natural plant resins. Now, flux is an important item in soldering work. It is having three roles. First, it melts before the solder at about 90 degree and removes any oxides or any dirt that is there on the surface of the metal and molten solder. It reduces the surface tension or the stickiness and improves the wetting of the solder. Third, it covers the surface of molten solder to prevent reoxidation. Types of solder flux. First is rosin flux. This flux is usually made from extracts of oleoresin pine trees. There are three different categories. First is rosin activated or RA flux, rosin mildly activated, and rosin flux. Next type of solder flux is water soluble flux. This is also known as organic acid flux. It is made from organic substances other than rosin. Also, such fluxes have ability to clean or remove the oxides for soldering purposes. However, you need to be quite careful while cleaning PCB assemblies with this flux. Third is no clean flux. Like unlike other flux types, this flux does not require any cleaning once you are done with the soldering. Next are solder joints. Ensuring the solder joints are made correctly is primary importance for any electronic constructions. Solder joints that are poor will either cause the equipment to not work once it has been completed, or this is the possibility that the solder joint could fail uh, or introduce noise into the electronic circuit. While complete failure of a joint immediately has been made is bad enough, um, intermittent failure can be worse as it can cause the equipment to fail once it is in service. Next, solder joints are of different types. First is good solder joints. Now, fortunately, most solder joints are good and do not cause any problems. The good solder joints will have a shiny finish to it, and it should not have too much solder. Typically, the contour of the solder around the joint should be slightly concave. Too much solder on a joint may lead to poor joints, and this is always possibility, uh, particularly on printed circuit boards, that if too much solder is used, then it could spill over on another track causing the short circuit. As you can see in the diagram, the ideal solder joint for a through hole component should resemble the diagram, that a concave surface. Next we have dry joints. Dry joints are main form of problem solder joints. These joints may be completely open circuit, or they may be intermittent, high resistance or noisy. It is therefore essential that no dry solder joints are present in any electronic equipments. It is easy to identify dry joints, unlike good solder joints that are shiny. Dry joints have dull or matte finish. Also, when soldering them, they appear to have a more granular appearance as the solder is melted. As you can see in the diagram, there are different types of joints, solder joints are shown. Next, we have solder alloys. A solder is a fusible metal alloy with a melting point or melting range of 90 to 450 degrees Celsius. Now, this is used in the processes this is used in the process called soldering, where it is melted to join metallic surfaces. It is specially useful in electronic and plumbing. Alloys that melt between 180 to 190 degrees are mostly used. Next, we have soft soldering, hard soldering, and mechanical and aluminum soldering. Soft soldering. Now, soft soldering is characterized by the melting point of the filler metal, which is below 400 degrees Celsius. The filler metal used in the process is called solder. Now, different combinations of tin, lead, and other metals are used to create solder. The combinations used depending on the desired properties. The most popular combination is 60% tin and 39% lead and 1% alloys. Another common composition is 11% tin, 37% lead and 42% bismuth and 10% cadmium. As mentioned before, tin lead solders are commercially available with tin concentration between 5% and 75% by weight. Hard soldering. Hard soldering or silver soldering performed with high temperature solder containing up to 40% silver is also often form of brazing, since it involves filler materials with melting points in the vicinity of or in excess of 450 degrees Celsius. In hard soldering, the goal is to achieve nice structurally sound joints, especially in the field of jewelry. Next is mechanical and aluminum soldering. A number of solder material, primarily zinc alloys, are used for soldering aluminum metal and alloys. and to some later extent steel and zinc. This mechanical soldering is similar to a low temperature brazing operation in that the mechanical characteristics of the joint are reasonably good and it can be used for structural repairs of those materials. As mentioned above, although there are many different types of solder that can be used in wave soldering, tin lead based solders are most common use. Next is soldering techniques. We have three techniques: hand soldering, hot air soldering and hot plate soldering. First is hand soldering. Now the hand soldering is the most traditional way we solder the surface mount device components. This is done by using a soldering gun. This might be difficult at the beginning, but after a few days of practice, you will get used to it. Generally, you can solder 1206 to 0603 packages by hand without much of a problem. Next, these are the steps like how to solder. Next is hot air soldering. This soldering method is bit easier than using soldering iron. In this process, instead of soldering iron, hot air station or and solder paste are used to mount the components. Here are step-by-step instructions to perform hot air soldering. Next, we have hot plate soldering. This process is similar to the hot air soldering, but instead of manually heating the components one by one here, a heated bed is used to heat the entire PCB board, enabling it solder all the components at once. Next, some of the tools which are used for soldering. Tweezer. A tweezer is useful and essential while soldering surface mount components because you just cannot grab assembly resistor and capacitor or any component with bare hands. So you require tweezer to put it. Then flux. Good amount of flux always makes the soldering neat and well finished. Flux removes oxidation or it removes dust and other particles, and it melts before the component the liquid flux is used before applying solder paste on PCBs. Flux comes in different forms like paste, pen and syringes. Then we have stencil. PCB stencil is nothing but a stainless sheet which has component a footprint cut into it, which is used. The PCB stencil is not required, but it certainly comes handy while there are too many footprints on the PCB. Then we have soldering stand. A soldering stand helps to hold the PCB in position while soldering. Now there are several variants of such stands in the market. Some of them come with a magnifying glass also, which is inbuilt. Next we have desoldering pump. Now this is used to remove the solder. This can come in really handy if you need to do some rework. Okay, so you need to remove the solder and if you want to again solder. Then you have hot air rework station. This station will come into picture if you choose to solder your SMD components by hot air method. This equipment makes the solder joint by blowing hot air to the joints. The temperature of output air ranges from 100 to 300. These are the references. Thank you.